We start our tour with an introduction to Git, what it is, and its basic concepts and terminology. When working with code and related files, we want to back it up for safekeeping, just like you back up those precious photos or your phone to the cloud. We want to save versions of the code, so if we make a mistake and close the editor, we can still get back to a prior version. Similar to how you might save versions of an important document, rough draft 1, rough draft 2, and so on. And we want to compare code versions to see what we changed, just like you can with Microsoft Word or Google Docs. Git does all of this and more. Git is a widely used version control system. A version control system is an application that backs up our files and tracks changes to those files. Each set of changes is a version, hence the name version control. Git runs locally on your computer and is available on any platform. You can download, install, and use Git without any cost or fees. As with most technologies, Git has its own set of concepts and terminology. A repository, or repo for short, is a storage box of sorts that stores the versions of our project files. As we make changes to those files, we commit, or copy, those files into the repository. Peeking inside the repository, we see that it keeps a list of all of our committed changes, called a commit history. Let's walk through an example. Say we've been busy working on several projects. To keep our code and associated files organized, we keep the files for each project in a separate folder. Here is a folder for the recipes app we're building, our virtual pet cafe website that we've started, and the sports store project we're creating with several of our friends. Each project folder is referred to as the working folder for the project. We use this folder to create and edit the files as we work on the project. We want to back up the code and track our changes for each of these projects. That way, if we start to make changes, mess up, and want to go back to a prior version, we can. We use Git to initialize, or create, a repository. You can think of this repository as a storage box that stores the versions of our project files. Since we have 3 projects, we initialize 3 Git repositories, one in each working folder. Let's take a closer look at our recipes project. Here is a visual representation of the project's Git repository. We'll talk more about repositories in detail shortly, but for now let's simplify it a bit. As we add or modify code in our working folder, Git notices the changes. We want to add a feedback option for users to provide their experience with a recipe. To complete this feature, we add a new file to our recipes project. I'll color code the file to indicate that Git recognized this new file. We also update one of the existing files. I'll color this one as well to show that Git recognized that the file was changed. When we're done with a particular set of changes, we commit the current state of our project to the repository. Git no longer sees the files as changed in our working folder, so I remove the color coding. It's important to note that committing our project files does not affect the files in our working folder. We can continue to add and edit files as needed for the project. Git retains that commit, which is a snapshot of our project files. Does that look sort of like a Polaroid snapshot to you? A snapshot is a picture or copy of our committed files at that point in time. Git assigns a unique identifier to each commit. As we work on our project and commit our changes, and work on our project and commit changes, and work more on our project and commit changes, and so on, the repository retains our commit history. We can examine the files in any commit or compare files in the commits. You may have noticed that we've been using commit as both a verb and a noun. As we make changes, we commit those changes to our repository. This is a common Git process. The result of committing our changes is a commit. Each commit saves all the project files. The commit contains a snapshot of the project files, including the current changes, and a unique identifier generated from the commit. This identifier helps Git track our commits. Another key feature of Git is branching. With branching, we create an offshoot of the main project to separate our work for each task. It helps us isolate and work on one part of a project without directly impacting the rest of the project until we're ready to merge it back in. By default, when we initialize a Git repository, Git creates a branch, often called main, though you may see it with other names. We'll refer to the primary branch as main throughout this course. We create a separate branch for every issue or feature we work on. So as a feature is in progress, we commit our code to the branch for that feature. Say, for example, we expect to spend a week working on the Add Feedback feature that allows users to comment on a recipe. As we work, we commit our edits to the Add Feedback branch. Suddenly, we receive notification from our users that the login isn't working. We create a new branch to fix that issue without impacting our partially complete work. When the code for the login issue branch is complete, we merge the branch back into the main branch and optionally delete the merged branch. We use branching to keep a working version of our code in the main branch and partially completed code in feature or issue branches. That way our main branch always has a working version of the code. But Git doesn't enforce this. It's up to you and your team to define if and how you'll use branching. So, Git is a version control system. With Git, we initialize or create a repository, then commit or copy our project files into that repository. That way Git can track file revisions. The repository stores the commit history for the files in the project. As a verb, to commit is the process of copying a set of files to the repository. As a noun, the commit is the resulting set of copied files. Each commit contains a snapshot of the project files and a unique identifier which is generated from the commit. A branch is a separate set of commits for a particular task, such as a feature, change, or issue. Now we know what Git is, but how do we use it?